Hello friends, this question is from Work Energy Power chapter. The question is, a block of mass m is suspended by a string which passes over a light and frictionless pulley. If another end of the string is pulled by a constant force F and kinetic energy of the block increases by 10 joule in 2 seconds, then the correct option according to the above data is to understand. And before looking into the options, let us draw the diagram of for the given description. It is given that there is a pulley, okay, and a block of mass m is fixed to a string, suspended by a string which is passing over a pulley like this, okay, and at the other end a force F is acting. Fine, a constant force F is acting, and as a result a kinetic energy of the block increases by 10 joule in 2 seconds. So kinetic energy increases by 10 joule means change in kinetic energy is 10 joule in 2 seconds. In that is 2 seconds 10 joule of energy increases. 1 second 10 by 2 is equal to 5 joule increases. So delta K is equal to 5 joule per second. Actually it is increasing 5 joule per second, so you can take it as delta K by delta T equal to 5 joule per second, and delta K is 5 joule is increasing because of the application of this force. Now which of the following options is correct? If you observe here, the tension in the string is mg, is it right? Under this condition, if you want to observe this, if you draw the forces, if you mention the forces acting on this, mg acts vertically downwards, tension T acts over here, and of course here tension T acts from this point here, and here also tension T acts, and at this point when we are pulling here, tension T acts upwards. So this force is pulling pulling this down, just if you are pulling down with this force. As a result of this, it is also mentioned that it is moving up with an acceleration, it is moving down with an acceleration. Let us say now in this case, if you write equation of motion as it is moving up, you can say T minus mg is equal to mass times acceleration. So as a T minus mg is equal to this, you can say T is equal to ma plus mg or mg plus ma. T is equal to mg plus some value, but T is what is that? The tension in the string is mg plus something, but is not equal to mg. So tension in the string is not mg, is mg plus something. Next, tension in the string is F. Is it? Let us check. Here, if you write equation of motion for this point, other end point, it is moving down with an acceleration a. So here the force F is acting down, and the tension T is acting up in this at this point. So if you write equation of motion, F minus T is equal to mass times acceleration, but at this point there is no mass, so you can say is equal to 0. So F minus T is equal to 0, or F is equal to T. So tension at this point is equal to what? F. Tension is not equal to mg, but tension is equal to Fs. This is right, but obviously tension is equal to F, tension cannot be 2F, right? And work done by the tension is 10 joule in 2 seconds. Is it right? 10 joule in 2 seconds means 5 joule into 1 second. Is it right? To cross check that, you can use what is the work energy theorem. Work energy theorem says that work done by net forces or all forces is equal to change in kinetic energy. Work done by all forces means what are the forces acting here? One is gravitational force, work done by gravitational force, work done by tension force, tension is acting. So this is equal to delta K. So work done by gravitational force, you can say mg plus mg into S, tension force is T into S for a given displacement. If you consider as mg here, if you can say that, if you observe from this, you can say work done by tension force WT is equal to delta K minus double delta WG, that is delta K minus work done by gravitational force. But in this option it is given that work done by tension is 10 joule in 2 seconds or 5 joule in 1 second. 5 joule in 1 second. So actually we have observed that kinetic energy is equal to 5 joule, the total one, but that is the total work done by all the forces is equal to change in kinetic energy, this is 5 joule in 1 second or 10 joule in 2 seconds. But only due to tension force, it should be kinetic energy minus something. So kinetic energy should be less than 5 joule in 1 second, but it is mentioned as it is 5 joule in 1 second. So it is wrong. This is also wrong. So only the correct option is the second option. Is it clear, everyone? Yes.